Okay, hi everyone. Welcome to today's OFSC Hazard 2020 webinar series. Today's presentation is focused on articulated mobile cranes. My name's David Denny, I'm the Federal Safety Commissioner, and I'll be hosting today's webinar. I'd like to acknowledge the traditional owners on the lands on which we're meeting today, both here in Canberra and around the country, and pay my respects to their elders, past, present, and emerging. Format for today, you'll see a quick introduction from me. I'll then hand over to our presenters for the main course, after which I'll facilitate a question and answer session. The OFSC is very privileged today to bring you some of Australia's leading crane experts. You'll be hearing from Rory Bracken, National HSEQ Manager, and Tom Clark, National Technical Heavy Lifts Advisor from Fulton Hogan. You'll be hearing from Brandon Hitch, CEO of the Crane Industry Council of Australia, and you'll be hearing from Technical Safety Officer Julian Bedford. Why are we talking about mobile cranes? Mobile plant is one of the two focuses of the OFSC's current Hazard 2020 campaign. We selected it because our data showed that it was consistently over the last 3 years one of the highest areas of non-conformance with scheme requirements, and was consistently one of the leading causes or factors involved in safety issues that are reported to the OFSC. The OFSC is now about 3/4 of the way through its Hazard 2020 safety campaign, and while mobile plant compliance is improving, the one area where we're seeing consistent areas of concern or decreasing areas of compliance is actually in mobile cranes. So at the end of June, we'd completed just under 200 audits involving mobile cranes across Australia, and 1 in 3 companies were struggling to meet scheme requirements with respect to mobile cranes. In particular, we were seeing concerns in relation to companies developing safe systems of work for mobile cranes, taking into account ground conditions, lift plans, and lifting of materials and workers. And we were seeing increased rates of non-conformance with respect to having systems for inspection and maintenance of rigging and lifting equipment. Of course, cranes aren't a new problem within the industry. Safe Work Australia data shows that between 2003 and 2015, 47 workers nationally were killed in incidents involving mobile cranes. So today's webinar focuses particularly on articulated mobile cranes, and that's because they're the most common form of crane within the industry. While I'd love to have covered a bit more about cranes, we just simply don't have the time within the hour that we've got. But if there is interest, we can look at doing further crane seminars in the future. So with those opening remarks, guys, I'm going to hand over to our experts to lead off on today's presentation. So over to Rory, Tom and Brandon.
Thanks for the introductions, David, and allowing Fulton Hogan and the Crane Industry Council of Australia to present today. As you mentioned, I have the experts in the area with me today being Tom Clark, Fulton Hogan's own internal advisor, and Brandon Hitch, the Crane Industry Council of Australia CEO. Over 4 years ago, Fulton Hogan recognised the continuing risk of side slopes on articulated cranes and set about doing something about it. Fulton Hogan developed and continues to develop training on this issue for our internal people, which has certainly seen a marked improvement in understanding and risks involved, and more importantly, the safety on our site with regard to articulated cranes. This training is also seen as one of the best in the industry, to the point where Tom now delivers this training to industry, government bodies, as well as regulators. Fulton Hogan are also on the technical working group for high risk licences and the industry representative for the National Assessment Instrument, with the task to improve the understanding and operation of Frannas, especially with regard to side slopes. The presentation today draws from that training that we've developed and looking to raise the level of understanding of side slopes and Frannas within the industry. So I presented the forum. Frannas and articulated cranes are probably one of the most popular and widely used cranes in the industry, and they're probably also the most misused or misunderstood, obviously having their own unique characteristics and behaviours, especially compared to slewing cranes. So what we want to present today is a baseline understanding of these cranes to a wide audience as to how articulated cranes operate, the risks they pose, and how to safely operate them on site. Fulton Hogan's closing in on nearly 90 years of operation now, starting in Dunedin, New Zealand in 1933. We're now in a broad range of sectors with significant vertical integration and a broad understanding of safety and risks in multiple industries. Without further ado, I'll pass you over to the experts.
Very good. Thank you to everyone who had an interest to learn about cranes today, but also the opportunity for CICA to share some of the important facets of articulated cranes in particular. CICA represents, as an industry association body, we have a national footprint with members from around the country that encompass crane owners or people that sell lifting services, as well as the crane manufacturers, and also the hook side of things, the rigging equipment, the rigging, slings, shackles, clutches, so on and so forth. Those providers as well make up our membership. So we believe we have a full spectrum of participants that can aid to improving safety in the industry. One of those things that was a self-initiated program back in 2002 was the Crane Safe program, and hopefully many of you are familiar with that program. It continues to be a gold standard globally for independent third-party crane inspection itself. It's the only program that's not accredited in Australia. With the footprint that we have in the membership for manufacturers as well as users, it's important for us to be able to contribute and raise the awareness and also the modernization of Australian standards. So we're very fortunate. CICA has the opportunity to participate at both the international level with ISO as well as being chairs of the local Australian standards, which do have strong linkages back to European and international standards anyway. I'll just jump into the specifics. It was important for us, as Rory said, the articulated mobile crane is a very popular crane. Over 40% of the cranes that are mobile cranes in Australia are articulated cranes, but there's a bit of a legacy, I would say, in the perception. And I think that our hope today, and when Tom and I and Rory looked at trying to draft this information, we want to raise your understanding of the perception of how articulated cranes or non-slewing cranes, the colloquial Franna crane, is used and perceived in the industry. I thought it was important to start with this slide here because this indicates the legacy and probably the misconception of the non-slewing crane and the articulated crane that we'll use synonymously. So quick point here, if you can operate a slewing crane, so I've shown a license C2. This slewing crane is a little Maeda crawler crane that you might be familiar with. Most of them have a 2.8 maximum rated capacity. The misconception in the non-slewing crane, articulated crane space begins in the licensing requirements. The fact that slewing crane licensees are legally able to operate the non-slewing cranes or articulated cranes. And I think that that's, again, leads to the misconception of a slewing crane operation is similar to a non-slewing crane operation. This is an area that CICA and Fulton Hogan are attempting to resolve through both the Safe Work Australia program of work around crane licensing, but also even in the current national assessment instruments, we're trying to elevate the state of questions as well as the units of competency to reflect current non-slewing cranes. We'll go and unpack that a little bit more in the presentation as we go. First thing I'll do to attempt to kind of shed a light on the differences or the variations that shouldn't be overlooked is that let's look at what a slewing crane, how it operates. What you can see in this slide, I hope, is first and foremost, it has a 360-degree rotational lifting capacity. All those numbers in that chart are ton rated capacities of a crane in that boom length and radius. If it's lifting over an outrigger, if it's lifting directly over the rear, if it's lifting over the side, that lifting capacity is constant in a 360-degree chart. What does that mean? Well, it means that in the course of picking and slewing, you're not changing the capability of the crane and its safety margin, let's say, that's built into the rated capacity. Before we jump and compare the rated capacity chart of a articulated crane or a non-slewing crane, I just want to highlight one other point since I've got your attention. If you see the two pictures at the bottom half of the slide, it's important that Tom and I wanted to express how adding a load to the hook significantly changes the center of gravity of the crane, and subsequently that change in center of gravity has an impact on the stability of the crane. The stability of the crane also impacts ground conditions. If you look on the left hand here, at a minimum, you'll be able to notice that the center of gravity is rearward in vehicle position to the slew center. And this, it's actually 1.06 meters behind, but it's also 2.4 meters high. 2.4 meters high matters when you start talking about any sort of side slope we'll deal with, or if you're in a barge application, the height of the center of gravity matters just as much as the horizontal displacement. The moment a load is lifted, not after it's 10 meters up in the air, not after it's at the hook height, once it leaves the ground, the center of gravity of the system shifts. All the forces from this load get resolved at the boom tip of the crane. Instantly, again, millimeters after that load lifts off the ground, the center of gravity shifts forward. So we see a 2-meter shift forward. Now the center of gravity is in front of the slew center. So your contact pressure of the crawler tracks has completely changed from a triangle facing rearward to now a triangle facing forward. You can also see even though that load is only lifted millimeters off the ground, the center of gravity jumped from 2.4 meters vertically to now 4.7 or nearly 4.8 meters. That's because of these resolution of forces I was referring to at the boom tip. The longer your boom, the higher that load center of gravity is going to impact the system center of gravity height. This is a very important thing, and these are physics that don't matter or don't really care about the crane type, the job site, the state, the country, the continent, whatever. This is, back to first principles, and understanding a basis for this for all cranes is very important to establish where incidents can occur and how they impact on things like ground pressure, how they impact on side slope, things like that. Now let's shift gears, and instead of looking at a 360-degree chart, non-slewing cranes, by their nature, articulate. It would be preferable and probably easier for all of us to understand if we called them articulated cranes, not non-slewing cranes. In essence, if you watch this motion of this blue crane to the top right hand of the slide, hopefully this will come across, you can see that's the full range of motion of that crane. There is not a 360-degree chart. It's that approximately plus or minus 35 or plus or minus 40 degrees. What's important in that is that articulation changes the stability of the crane, not because of ground conditions or anything like that, but because the stabilizing moment that's called out here in this top view diagram moves forward closer to a tipping line. So what this top view diagram is showing that the tipping line is the front tires. In a very similar fashion that on a slewing crane with outriggers, the tipping line would be the box of the outriggers. But because these operate on tires, the tipping line is the front axle. You can see between the straight ahead position versus the articulated position, that stabilizing moment reduces in articulation. The distance from here to the tipping line, if you can see my cursor, compared to that green line on the bottom picture, it's forward and closer to the tipping line. That reduces the stabilizing moment. What does that mean? Back to the load chart, you can see there's different rated capacities for different articulation angles. For straight ahead, in this example, which is a AT40, there's 22.3 ton straight ahead lifting capacity. Because it's governed by stability, that's reduced when the stabilizing moment is reduced in 20 degrees, up to 20 degrees articulation, it drops 50%. So you go from 22.3 ton to 11.6 ton. Once you go beyond that 20 degrees, you drop a further, let's say 40% to 8.8 ton. And that's the range of motion that you are able to utilize for its rated capacity from 0 to 35 degrees. You're essentially, you have, if 22.3 ton is your straight ahead capacity, you lose 60% of that capacity in full articulation down to 8.8 ton. I'll ask you the question, and Tom, you can elaborate on a few other models, but how often do pick and carry cranes, articulated cranes, just drive straight on your sites? And more importantly, I guess, how often do they pick up a load straight ahead and then proceed down a path that involves articulation? That's why this nuance of non-slewing cranes is so important in planning the lift. So I'll hand over to you, Tom, for a second.
Yeah, we're looking at the AT40. There's different models of the Franna. There's an AT22, which has a 0 to 40 degree articulation. It doesn't have a split chart. The AT20 and the Mac 25 have 0 to 10 and a 10 to 40 degree. However, going on what Brandon said, when you're talking to crane drivers, you've actually got to ask them the question, have they planned their path? The problem we see in the industry at the moment is people are well aware now, because of the recent incidents with side slope deration being a problem, they forget about the articulation, and that heavily reduces the stabilising moment. And what we say to drivers out there is, tell me where you're going to go. Are you going to articulate to pick this load up? And if you are, have you considered the articulation, then the side slope? And that's the most important part. On the next video, you'll see the difference of how the behaviour of the crane and the boom happens when they get on a side slope. Okay, so this is an indication of the crane, and pay particular attention to the block he's got. He's roped up for 4 parts of rope. That's heavily important when you're dealing with Frannas, because it does affect the chart going forward. If you have a look at the side slope, have a look at the hook block, it's out of the centre line of the crane. So the stabilising moment's already on the tipping side. So if you have a look at it, how it says the hard surface, there's certain percentages and degrees that you have to fall within the chart, and you have to look at that chart prior to your operation of the crane. This is what a lot of drivers don't do.
Like Tom was saying, Firm level ground is described in Australian standards and where load charts are derived from as anything between 0 and 1%. 1% is less than 1 degree of side slope. But what you can see in this chart, you can see that this chart is applicable up to 5 degrees, or again, in an inclination percentage is 8.75. So anything over a 5 degree side slope should be considered a design lift and will have its own level of scrutiny and checks and balances associated with its beyond normal operation up to 5 degrees. Tom, I'll hand over to you as far as if you want to explain the chart, and then the video hopefully will give you a little bit of further discussion around how the impact of what's seen in this chart plays out.
Yeah, so Brandon's not actually picking these numbers. These numbers are actually in the Australian standard. They're in 1418. And if you have a look at the crane, you have a look at the degree. So the further the jib goes out, you've got a fly jib at the end of that, and it's going 10, 20, and 30. Then you start coming closer, 30, 40, and 50. Then it goes 10, 20, 30, 40, 50, and 60. If you have a look at that and look at the durations, the jib is out. The further you put that jib out on a side slope, the more you have to decrease that load chart. The centre of gravity is up the top. It's hanging off the centre of that crane, and you're in trouble. If you have a look, you say 60, 50, and 30, and people always say, well, how come at the highest point you're reduced? Well, that's structural load indications of the fly jib, and she would only be on a single line. The capabilities of the crane lifting on single line is reduced significantly. If you go to the 50%, it'd be very rarely he'd be lifting on 4 parts of rope there. He'd probably be on 2 parts of rope, which means the purchase on the crane, and I'll explain that. You go back to the winch. On these particular cranes, they have a line pull of 4,200 kilos. So if you increase that by 2, it's 8,400 if you have 2 parts of rope, and then you go down and then you have 4 parts of rope. Significantly, the issue here is the height of that hook going up with the centre of gravity on the side slope. So that's the deration chart that explains what you've got to deduct from your rated capacity. After you've deducted your articulation angle, then you deduct this off your rated capacity to give you your final number of what you're capable of lifting, including the hook block, the rope, and any associated rigging gear.
And I think that one of the biggest takeaways from anyone who's not familiar with this side slope duration chart is exactly what Tom said. This is the reduction in rated capacity, not the new rated capacity. That's a common misconception. You'll see this in the video that we're about to play. And the other thing I'd call your attention to and watch out for in the video, we talked about the tipping line being the front axle when you're on flat level ground. When you're on a side slope, the tipping line can also become the side of the crane where the tire profiles are touching the ground on the side. So what we're showing in the front view with the load CG and wheel line, you'll be able to see how that changes as the boom is extended. And that should hopefully correlate to this chart of different rated capacity reduction. Just watch this video, and the video will go through an example of how to apply the reduction, and then we'll go through a worked example quickly.
Here we see a pick and carry crane on level ground with a load suspended from the boom. The load and its centre of gravity are within the stability base of the crane. But if the crane was on a cross slope, the load will swing outside the line of the crane's base, creating a side load, and the crane could tip over sideways. This side slope would not increase the working radius. However, the crane's stability base is decreased, as the crane's tipping line is now the wheels on the load side, not the front wheels, as in the facing downhill situation. And note how the side loading will increase the longer and higher the boom is. This is why manufacturers always recommend that when traveling with a load, keep the crane's booms as short and low as possible. Some manufacturers supply charts that allow the operator to determine a rated capacity for the crane when working on a known side slope. These charts show a percentage of duration required for the given boom length and angle, and the duration is applied to the rated capacity as read from the load chart. For example, using the chart shown, with a 15-metre boom length at a loaded boom angle of 45 degrees, the rated capacity of the crane is 3,700 kilos, if it is slewed greater than 10%. This rated capacity assumes the crane is working on firm level ground. But if the crane was on a side slope of up to 5 degrees, the duration chart shows for a boom in this position, the rated capacity must be derated by 40%. So 3,700 kilos minus 40% equals a rated capacity of 2,200 kilos, a reduction of 1,500 kilos. This is the maximum load that the crane can lift to stay within safe margins. Otherwise, you run a real risk of overturning the crane. And the rated capacity will be even less than this if you slew the crane more than 10 degrees.
All right, hopefully that video helped depict a little bit of what happens when the boom is extended and why that rated capacity chart shifts from 20 and 30% to 30 and 40% as you extend the boom. Tom, do you want to walk through just a quick rundown of this example that shows the crane on a 3.7 degree side slope? So it is more than the 1%. So we should be applying the side slope chart.
Yeah, if you have a look at it, if you go to the 4.5 radius, it's indicating 7,300 kilos. Then you go to your side slope chart and you're looking at the 40% reduction. You have a look at what your reduced rated capacity will be. And always remember in the rated capacity that you must include the hook block, the rope, and whatever rigging gear you've got in it is another further deduction, which people don't seem to do out there on site. The boom angle's 34 degrees. And I say to people, don't worry too much about boom angles because you have to go to this chart and then look at it. The best way to do this chart is to look at the radius and look at boom length.
And what Tom's talking about with that 40% reduction, that means when you look at the non-side slope rated capacity of 7,300 kilos, you take that times 60%, because that's the 40% reduction from 7,300, and your overall maximum rated capacity after all the deductions are included, like Tom's discussing, where you add the hook block to the weight of the load, you add the rigging to the weight of the load, the most you can pick up is 4380. If you consider how much that changed by 40%, and we also saw that on the AT40, you had a over 60% change in straight ahead to articulated, you start stacking all this up just to reinforce. If you're picking up straight ahead on flat level ground and it's in the green, articulating or going to a side slope can quickly put the rated capacity at or above 90% and engage that amber or orange light, or in some instances, engage the red 100% capacity light. These things need to be planned through the course of the lift, not just taken for granted like a slewing crane would be.
On a crane, you'll see 3 lights on it. One will be green, one will be amber, and one will be red. And what that indicates is it's linked to the LMI, or the rated capacity indicator. What happens is when you're lifting up to 90% of the chart, in this case, these cranes are rated at 66.6 by the Australian standards and EN 13000, it will remain green. If you go over 90%, the amber light will come on. If you go over 100, the red light will go on. A lot of people don't understand how the amber and tri-lights work, what you've got to indicate with the crane driver. And have you planned to be in the 90%, you should have an amber light. What happens out there is people don't plan. And what's also important with these Frannas and should be taken into account is your tyres. The maintenance on these tyres is highly critical because they rely on tyre pressure and the right tyres being on the machine. The second point is they punch out a lot of pressure. People don't understand that Frannas would probably punch out as much as a 250-tonne crane. Planning the path is very, very important. The risk assessment on the path of where you're going, if there's potholes, services, depressions, or even a little bit of a side slope, you'll get a dynamic loading on the hook. And that's highly important when talking to the Franna driver out there in the consultation process.
I realize we've had a very abbreviated time to digest what I would consider certainly a very, very important matter about considering side slope, but also to a novice that's not overly familiar with these type of things, you get lost easily in the terms alone. So I apologize for that, but hopefully that we can unpack some more detail in the question and answer time. We were just talking about also including a little bit of what's next. While we've talked about side slope, we've talked about rated capacity, all these type of factors, it's really highlighted and focused only on the site-based activity. For the articulated crane space or the pick and carry crane space, what's up and coming in the future is a consideration for on-road driver licensing. Historically and at this present time, It's only ever required a medium rigid for some states or a heavy rigid truck license to operate these type of cranes on road. What that license generically fails to do, in the same way that a slewing license for site activities fails to do, is consider the impact that articulation joint instead of conventional steered axles has on the maneuverability of the crane. This is a project that's been underway for the past 12 months with Ostroads, and NHVR has been working for pre-COVID on modeling vehicle behavior in response to a coronial inquest up in Queensland. So there's work being done on this, and it'll likely lead to an on-road component to heavy vehicle license for articulated cranes. CICA, just as an update and the matter of kind of bridging the gap, CICA has been involved in this process for quite some time, and also, like all processes, sometimes can take too long for what could be a simply identified risk to resolve. What we've incorporated with the CrewSafe program, our verification competency system, when an articulated crane operator is being assessed, every operator has to drive at highway speed, and every operator who is assessed on an articulated crane, a video is captured of them demonstrating driving on highway speed. You can see in the screenshot here from an iPhone, the orange camera light indicates it's a mandatory video, and that video is a 3-minute video showing this operator driving through traffic with his assessor sitting next to him or her. This is captured through the CrewSafe program, and then it can also be referenced by employers as well as any site officers to see this being demonstrated, not only for driving at highway speed, but any of the videos that are mandatory videos. As you can see in the background, there's a couple other videos there for leveling the suspension, road travel, and so forth. We try to use the CrewSafe app to capture that while regulations are being developed to formalize a licensing scheme. That's all we've got for the presentation portion of this video conference. Again, on behalf of CICA, thank you for the opportunity.
Yeah, thanks, Brandon. Thanks, Tom, for presenting that. I think there's plenty of information in there, even in such a short period, that I think we can take away. And I think it's really provided a lot of insight into the safety risks of articulated cranes. And I guess what I hope we've provided is some food for thought as to how you may currently operate your cranes on site, and as well as the types of questions that you may now need to start asking your crane contractors on site. And we look forward to some of the questions later on in the presentations.